So today we can start Kubernetes, right?
Sure.
So anyone worked before Kubernetes or any idea for the new joiners? Any of you?
It is a container orchestration tool.
Right. Yeah, it's a container orchestrator. And actually, before Kubernetes, we deploy our application to Docker, right? Or any serverless, cloud-based serverless platform like ECR or ACR like that. Sorry, ECS, okay. ECS, Azure, coming to Azure Container Services, okay, ACS. So similar type platform we use, but that's a platform only, okay. So coming to Kubernetes, it's a container orchestrator. Container orchestrator. So the Kubernetes automatically deploy or scaling, then managing our containerized application if we use Kubernetes. So it's a container orchestration platform. Okay, it's a container orchestration platform. So this will or that will help manage and deploy containerized applications to scale. So this contains, it follows master worker architecture actually. So there is two architectures are there. One is master and worker, and this consisting of control plane components and worker nodes as well. For example, if we set up a Kubernetes cluster, we call it as a Kubernetes cluster. Okay, so the uh, cluster contains two parts actually. One coming to the main part, we called as the main master part. And the second, worker. For both, we called Kubernetes cluster. Okay. And coming to the master part, there are some components are there. And also coming to worker part, some components are under the worker part as well. So for the entire master and worker, we call as a Kubernetes cluster. So for example, where we are using Kubernetes, okay. We know we have Docker environment to deploy container application. Then why we using Kubernetes? That is actually coming to Docker environment. There are so much limitations are there. Okay, for example, if we're running multiple containers are there. Okay, for example, we run some application Docker. Okay, application that application contain a lot of services like 50 or 50 containers are there. Okay, or above 50, consider like that for a single application. But as a human, there's some limitation, right, to managing those containers. For example, daily we need to look all the containers and checking the logs. And if any container is stop state or exit state, we need to manually managing that application container, right? So it's a tedious task when coming to a production environment, because for a single application, we can see 50 containers. Consider like that, we have multiple applications, similar like 50 or 20 like ports there. So that's a lot of, I mean, it's a tedious task as a human being to managing, scaling all these stuffs, right? So there the Kubernetes came actually, okay. So coming to Kubernetes, we don't bother about these tasks, like for example, checking the containers, okay, daily as a routine checkup. We don't go and check the container status or anything, because Kubernetes automatically managing the containers. If any container is stopping or stop, the Kubernetes automatically starting the container and managing and everything. So that's why we are using Kubernetes in most of the production environments. Okay. So the thing is same, like how we are running an application using Docker. Similar way we uh, deploy the application. Not similar actually. We using the same image actually. Okay. For example, if we deploy an application using Docker, how we will deploy using the Docker Hub image, right? There is an image there for the application. So the same image we using in the Kubernetes platform as well. But the deployment way is different when comparing with the Docker. Because coming to Kubernetes, how we will deploy application using, I mean, writing a file, okay. For the Kubernetes parts, we need to write some files. The file name or the file format ending with the YAML for extension, okay. Like for example, we need to write a application. Okay, so we need to we need to deploy application. Okay, so we need to write the application manifest using YAML format. So app.yaml. So inside the YAML file, we need to define the application scenario. I mean, application version, application name, how many application instance there, the image, everything we need to define the application file for the Kubernetes deployment part. And yes, then different types of Kubernetes are there. Okay. So for example, managed Kubernetes are there. Managed Kubernetes. Second one, self-hosted Kubernetes. So if we can choose any of these setup, okay. And if we select managed one, this is managed by any of the cloud providers. So like, for example, AWS. AWS has a Kubernetes service. It's on Kubernetes service. So they called that service name is EKS, Elastic Kubernetes Service. For Azure, AKS, Azure Kubernetes Service. And G is Google, GKE, Google Kubernetes Engine. So which cloud provider that we use, we need to, we can configure corresponding Kubernetes service. For example, in AWS, we need to set up the EKS, okay, that is Elastic Kubernetes Service. So this is managed one. So the most of the Kubernetes, there is two parts are there, right? The master and the worker. So if you select the managed Kubernetes service, so the most of the cluster components or the services managed by the corresponding cloud provider. So there is not much troubleshooting that from our side we don't need to do, okay, because the for example the master part, okay, coming to master part, there are some components are there. So coming to the managed Kubernetes, most of the master part components managed by cloud provider. And the cost also high if we selecting a managed Kubernetes service. Then the second one is self-hosted. This is a scenario actually where we are setting the entire Kubernetes service with our own environment. Okay, so this is hard way. We need to set up everything. Like this is a simple way. Okay? If you're selecting the manager Kubernetes, this is a simple way of deploying Kubernetes. And also most of the applications, okay, production application we deploy mostly in the managed Kubernetes as well, like AKs or EKs. Then the self-hosted one, we have to set up everything like master part and worker part and downloading necessary components from internet and set up everything. Okay. So this self-hosted we can set up in local environment as well. Like for example, we have two laptops, right? So using that two laptop, we can set up the master and worker part. So this is setuping in setup Kubernetes cluster in local using local mission as well. Okay, like we can leverage EC2 mission as well. Okay, we need to set up two EC2 mission on one. We can make one as master and we set up another EC2 and this mission will be our worker mission like that. And we need to join this mission to the master part as well. So we can we set up a Kubernetes cluster from scratch. So that's come under the self-hosted. Then one more thing there that is Minikube. This is a tool actually. Using the tool, we can set up a Kubernetes working environment. Working environment using a single host machine. Okay. So in this, if you're using the Minikube, we can set up a single machine. Okay. Using a single machine, we can deploy Kubernetes infrastructure, Kubernetes. So where we are using these things, like for example, if you're selecting Minikube, then it's a mostly for learning purpose. Or else we can test some small scale application as well. Okay, two things we can do Minikube. And for self-hosted, it's good for the development piece. Okay, so we can set up this for the development piece and the managed one purely for production. Got it.
So for Minikube, there won't be master and worker. It's going to be only one thing.
Right, right. In a single machine, we set up master. I mean that Kubernetes. It's using Minikube tool actually. So the tool will bootstrapping Kubernetes cluster for us.
Okay.
Then I will draw the cluster once again, and we need to go through the components as well. Okay. So this is a cluster. Okay. Kubernetes, we called as Kubernetes as K8 as a short form. Okay. In between, so in between K and S, there is 8 alphabet are there, like U, B, E, R, and ETS. That's why we call as Kubernetes as like this. So this is our cluster. And there is two parts are there. One is master and next one is worker. Okay. And coming to the master part, there are some components are there. Okay. So 4 components are there in the worker part. So first part is API server. This is the first component. So next one is etcd. controller, and scheduler. Okay. So these are the four components comes under the master part of Kubernetes. Each component has their own duties actually. So coming to the API server, we called as Kube API server as well. Okay. So this act as a front end of the Kubernetes. Okay, or the entry point. We can call as the entry point of the Kubernetes as well. So why we call like this? For example, we deployed a Kubernetes or we set up a Kubernetes cluster, okay, console like that. And after that, we need to using a EKS, okay, or cloud-based run, like managed run. So the service is static, running and static and running, okay. And next thing is we need to connect to our cluster, right? So connection comes or go through the API server. For example, we have a local laptop here, and from this laptop to this Kubernetes server, this is one of the service in AWS, right? So we need to access the Kubernetes to deploy some application. For example, for that, we need to create a API call from our machine to Kubernetes cluster. So that request hitting to the API server. That's why it's a front end of the Kubernetes service. So the API server will taking the API request from the user or the one who managing the Kubernetes cluster and doing the things. Okay. So what's the request came from the mission? So it will take and provide the necessary things or like that. So this exposes REST API for interaction actually. Okay. So using the REST API. REST API. So the next component is etcd. So etcd is actually simply we can say like it's a key value store. It's a small size database, okay? It's a small size database. So this database contains the entire Kubernetes information, like how many like cluster configuration, state, metadata, everything contained this database, small size database. So it's store like as a key value. Okay. So the format is JSON. Okay. Coming to etcd, how this configuration, all these data store as a JSON format. So this is a small size database. The database contains everything of this entire Kubernetes cluster. I'm drawing the master part component as well. Okay. So coming to the worker part, some components are there. So the main component here is node. Node one. Here I draw two nodes. Okay. This is a node two. So as per the requirement, we can deploy more nodes. Okay. Like three, four, like that. So what is node? It's simply we can call it as a EC2 machine. So this is one EC2 and this is another EC2. It's a virtual machine. So coming to AWS, we leveraging EC2, right? So that's all. Also, we need to define the machine configuration like T2 or T2 medium, large, as per the requirement. So coming to Kubernetes, we called as node. So the nodes, whenever we set up in the Kubernetes cluster, some predefined or pre-installed services inside a node. Okay. So that's two services there or two components there. One is kubelet. Kubelet. It's a single word, okay. Then kubeproxy. Okay, one more thing there, container runtime. So I'm drawing like here, container runtime. So these three things came here as well. Okay, second node like kubelet, kubeproxy, and container runtime. Okay, so these three things also installed in this node part. So next thing is, yeah, that's fine. So the coming to the master part, controller and scheduler. Okay, so what is controller and what is scheduler? Controller actually controls like how many or runs multiple controls, okay, to handle cluster state changes. So coming to controller, there are three types of small controllers are there. One is node controller, then replication controller, and service account or service token control. Okay, so coming to node control, okay, inside the controller, here actually three types of controller are there inside. One is node controller, second one is replication controller, and third one is service account controller. So node controller has their own duty like monitoring worker nodes. So here we can see two nodes, right? So these are the nodes we need to monitor. So the coming to the master components, the controller, node controller will managing the our cluster nodes. So that's like monitoring in the sense of, for example, some nodes taking too much CPU utilization or memory utilization like that. So everything is monitoring, right? So this part comes under the controller, node controller. Then the replication controller, the next one belongs to the same controller component, that is replication controller. That replication controller manages the pod replicas. So I'm not drawing the pod part actually. So okay, we set up the Kubernetes cluster here. Okay. The next thing is we need to deploy the application, right? For deploying application, we have a laptop here and we authenticating, okay, using one files there. Okay. For the Kubernetes, we using config, we called as a kube config file, kube config. So the kube config file related to the corresponding cluster, and that file contains a cluster details. Okay, everything is inside the kube config file. Using the good kube config file, we authenticating our cluster remotely. Okay, any like server or any CI/CD platform like that. So using the kube config, we authenticate our cluster, and then we can work with our Kubernetes. So coming to Kubernetes, we use one command line tool, that is kubectl. This is a native command line tool to interacting with our Kubernetes. So we need to install the kubectl in our local machine where we are running or where we are managing the Kubernetes. Okay. So next thing is we using kubectl command, and some commands are there. Okay, using kubectl. So we need to learn that. So using the kubectl command, we will authenticating with the API server and doing our job like application deployment or getting machine configuration details, or how many nodes are there, how many ports are there, how many containers, I'm sorry, how many services there. Everything we need to checking with the kubectl command. Okay. So the next thing is some other components are there that I will explain with the application deployment. Okay. So now we are going to deploy one application. Okay, so for that we need to install the kubectl, then authenticate with the Kubernetes cluster. Then we need to write the YAML file in our local machine. So app.yaml. So inside the YAML manifest, we need to define everything like application detail, configuration, which image that we are using for the application. So that image actually we need to define from define the Docker image. Okay, so whenever we applying this YAML file from the local machine to Kubernetes, the Kubernetes is taking the YAML manifest and execute. I mean, taking the request and automatically deploy the application using the YAML file. Okay, so yeah, first we need to write the application scenario. Then using kubectl command, we need to apply the YAML file from the local machine to the Kubernetes cluster. So the API server will taking the request. Okay, then sending to the next components like controller, schedule, like that. And finally, the scheduler will sending the application or schedule the application deployment to the corresponding node. So here, coming to node, we can see one more component that is called pod. So inside node, we can see one more service called pod, and we deploy the application, okay? And inside the pod, we can see the container. This is the actual container. Inside container, we can see the application. Got it. So there is a pod. Pod is actually, it's a like it's a small deployment unit. Okay, smallest deployable unit in Kubernetes. It's contain one or more container sharing the same network and storage within the pod. Got it. So the pod, why we using pod here? Because the master pod does not communicate directly to the container. So we set up a pod actually. Inside the pod, there is the application container belongs. So that pod contain one or more container there, okay? And now this is fine, okay? So this is the final view of the application deployment using Kubernetes. So here, some commands are there. We need to explain, like that is scheduler, controller also there. So the coming to controller, as we discussed, like it's contain some key controllers, okay, include node controller, replication controller, and account controller. So the coming to the replication controller, it's managing the replicas. So sorry, it's managing the port replicas. So coming to the application deployment, okay. So here in the YAML file, we define how many application we need. I mean how many instance of applications, identical application. So in this case, you can see only one container, right? So the best practice is we need to set up more than two, okay? So for if one container is down or having any issues, our second container will taking the request from the user as well. So in that case, we need to set up more than two container, okay, in the application deployment that we called as replica. How many replication of the application? That's meaning. So we need to define, actually, whenever we're writing the YAML file, we need to define that also. Coming to, there is a part called replica. So we need to define replicas as 2 or 3. That means it will deploy 3 applications. Whenever we are applying the YAML file, here we can see it's one of, here you can see only one port created, right? So the second port also created. Here I defined as 3, okay? Replicas as 3. And here another port created, also the container and the application. The next pod will be in same node or another node. Okay, that's all. That's everything managed by the master pod actually. But most probably the next container or the next replica will be deployed in another node. So here we can see the application, and this is a pod, and this is a container. So why we using replicas? For example, we using 3 replicas. Okay, so this if one of the pod having any issues, don't worry about our application, because the application relies on here as well in the next pod node as well. If any issues based on the node, okay, for example, one node is having some issues or going to down or like that, don't worry about that, because our application here in the next node as well. Got it. And that's all. Then coming to the controller, one more controller, one more thing there, that is service account and token control. Okay. So that is handling the authentication. Okay. So the service account and token controller handle authentication. Then coming to the scheduler. Scheduler actually, it will assign new ports to appropriate working node. Okay. So that's the main job of the scheduler. Also, it's consider factors like resource availability, non-health, and affinity rules as well. For example, here we have two nodes are here. Okay, so we deploy an application. The two application replicas are here, and one is there. So next thing we have to deploy another application using the same way. So in that case, this coming to the scheduler looking the node, how many ports are there now. So here you can see two nodes are there, right? So this machines having more CPU utilization because a lot of workloads are here, right? So the schedulers know another node there with the less than the node one, right? The CPU utilization memory. So the application goes to the next node. So everything managed by the scheduler actually in this case, like scheduling, assigning the ports to appropriate working node using resource availability and node health. So everything is monitoring actually. Then coming to the worker part components, that is kubelet, kubeproxy, and container runtime. So the kubelet is actually an agent, okay? That agent running on each node. So here we have two nodes. So in two nodes, we can see the kubelet. It's a agent. So that agent ensure containers running as expected. Also communicate with the API server as well. So this is the agent to communicate with the master part API. So it's a agent, and that agent contains all the worker node. If we deploy one more node here, then that is these components like the agent, proxy container, everything will be there. Okay, and it's ensure containers are running and everything it's monitored. Okay, and it will uh, create a communication between the master part as well. Then container runtime. Here one component is there, container runtime. The container runtime it runs the containers actually, because coming to Kubernetes we need container, right? So here you can see the containers are running here, running here, running. So how we will running containers? We can use Docker, right? Some alternatives are there for Docker like Podman. So coming to Kubernetes, by default, here a container runtime using is container D. Okay, similar like Docker actually, container D. Previously be using Docker actually, but it's not sufficient for Kubernetes part. So now it's mostly using container D. Different types of runtimes are there, like Docker there, container D there, then CRIO there. So these are the different types of container Ds. So coming to Kubernetes, mostly using container D. Okay. So the Kubernetes interact with its container runtime as well. Then kubeproxy. This is another tool. So this tool or this service manage network communication between ports and external services. So this kubeproxy is mostly for the network part. Okay. So this will implement Kubernetes service for load balancing as well. So whenever we set up the load balancer for exposing our application, so in that case, this service actually, okay, the Kubernetes service implementing kubeproxy for setting the load balancing. Got it. So this is the high level overview of Kubernetes cluster architecture and the components. So anyone have any doubt?
You told like the scheduler is the one who is checking the availability of
Not
the nodes.
yes, whenever it's deploying the application, okay, this is actually a scheduled process. For example, we deploy an application, so go through the API and finally it's come here. It's a queue system here, okay. So the scheduler will assign the application deployment to the best node. Best node, how the scheduler choosing one node as node is the best one. using the node availability and health check, everything is considered. Okay. After the scheduler choosing that's the best node, and we can use that node for this application deployment.
Why do we need proxy in that way, like for load balancing? Since it is doing that.
Not load balancer actually. Kubernetes is managing network communication between ports and external services. That's all. So load balancer, it's implement Kubernetes services for load balancing. Okay. There's an implementation process only.
Okay. So you meant to say like replicas. If you are given replicas as two, if like one of the pod went down and the other one is up, so it's going to spin up another pod again, making it as a replicas is two. It has to be a two pods at any time.
Right. You mean we have two replica, right? So one is here and one is in next pod, right?
Mm-hmm.
And if the pod one is going to down, it will automatically create another pod. That's the scenario, right?
Yes.
Yes.
Since we have given
No,
the
no.
replicas as two, at a time it has to maintain the replicas. At any point of time, it has to have two replicas. So if any one goes down, it's going to spin up the another one.
Yep. Right. So all these things we define in the deployment actually. Some resources are there. Okay, coming to Kubernetes.
So HCD database is the one. Are we going to deal with HCD database? Like maybe how we going to interact with it? Like in what scenarios?
ETCD database actually is a database. This database contain everything. For example, how many nodes are there? The node, how many ports, application deployment, like configuration, how many deployment there, application deployments are there. So everything is saved in the ETCD. Okay. So for example, okay, this is a database. Okay. So one scenario I will tell you. Okay, how this useful. First, coming to the production environment, we need to take a backup of this this etcd database. Okay, so that's the best practice if is backupping the database configuration. So consider like that, we backup that configuration. Okay, so backup is there in local, and okay, the cluster is running, application also running. So we accidentally deleting some application deployment is deleted. So what we will do, a quick way is we can using the backup. Okay, so in this case we deleted one application deployment. So deleted. So we need to go back, right? So back to the state. So we can taking the application backup data and attaching the backup, then it will automatically create the application using the backup. Got it. This is one of such example. And a lot of other scenarios are there. Like actually, this contain everything. Every data belongs to the current state of the Kubernetes. Current state means the last thing that we did here. Okay, that is the application deployment. Three application ports are there. So all the data belongs to the etcd data, etcd database.
You said there will be a three Kubernetes in the above slide. You said like we're gonna cloud-based service. We're gonna use cloud-based service as well as
Managed one, right?
for managed one and the self one. And are you gonna show us the lab for all the three of them or? It's going to be only one.
Yeah, all three.
Okay.
So coming to lab, first we need to go through the managed one. Then they'll force it there. Also we need to. So the setuping cluster, we have 3 labs actually.
Okay.
Then the rest of mostly we using managed one whenever we setuping the CACD part. I mean CACD pipeline. Then some other I mean points are there. That is coming to the Kubernetes part. Okay, here we deploy one application, right? Here we deploy. I told you using that replica. I mean the app.yaml file. We deploy 3 applications here. One node, second node, and the third node. So this is application deployment. Okay. So the next thing is this application is only accessible within the cluster. So we need to if we need to expose this application to the I mean outer world of this cluster, then we need to expose this application, right? So exposing, how we will exposing using services. Coming to Kubernetes, some different types of service types are there. So we need to select the corresponding service types to expose this application. For that, we need to write a service.yaml file within the local machine. Okay, so the name is service.yaml for the specific application. Okay, for the this running application. So inside the service.yaml, we need to define everything, how this application, I mean the service name, how this service type, I mean service is depending with the above application, everything we need to define. Then we need to apply the service.yaml file also to the Kubernetes. So it will create the service within the cluster. So different types of services there, that is cluster IP, I capital, C capital, node port, node, N capital, P capital, okay. Load balancer, L capital, B capital. Because whenever we define these things, we need to ensure that C capital, I capital, N, P, L, B. Otherwise, it's not taking, okay. We're facing some issues. So as per the requirement, we need to select corresponding service type for our specific service, I mean application, okay. So by default, sorry, but not by default. If you're selecting cluster IP, then what it means, for example, we need to deploy an application. Okay, I will tell from scratch one more. So, we set up the cluster. Okay, cluster is running, and then we need to deploy the application. For that, we need to set up the file for, I mean, setting the manifest. So app.yaml. This file contains the application requirement, everything. And for the same application, we need to expose the application. So we need to set up a service file for the same application. So the second file look like service.yaml. We can define the service configuration in the YAML, first YAML file as well, okay? But this is best practice. We need to keep a separate file for the service. And yeah, that's fine. And we apply the YAML for application deployment. And next we need to apply the service.yaml. And if we select, coming to the service, okay, YAML configuration, if we select the service type, there is a parameter there, type. So in the type, we need to define corresponding services. So if you select cluster IP, that means that's the above service. This application only accessible internally, okay, internal communication only within the cluster. So if you select node port, that application is exposed outside the cluster, and we can set up, sorry, we can set a static node port, static port actually. Okay, for example, if you're selecting node port, okay, so node port is actually using for exposing the application, but this using a static port. Okay, static port means for example, we have two virtual machine. Okay, here one is this and one is this, and we need to expose the application using node port. So the how we accessing the application, like the node machine IP plus the static port that we define. For example, one port number there, okay, like 3000. That coming to Kubernetes, the port number that we defined in between 30,000 to 32,200 and something. I missed that part actually. So there is a 2000 port, okay, 2000 something port we reserved for application deployment when coming to Kubernetes if you're selecting node port. Okay, so that's why we exposing the application. So the application running in the inside this pod. Okay, so we need to take that machines node IP with the port number in between 30,000 and 32,000 something. So that's why we accessing the application using node port. So if we selecting the type as load balancer, so it will create a load balancer actually. Okay, if the cluster is a managed one like EKS, so the AWS will automatically create a load balancer for us, and we can use the load balancer DNS name for accessing the application. So where actually we using these things? The cluster IP is only for internal communication, and the node port is good for the development case. Okay, for the development case, we can set up the node port, and the production we mostly using load balancer. So, for example, the we have a front end application. So the front end and a back end as well. Okay, so the front end and back end here. So the front end, this is a port, front end port, and this is a back end port. And inside the port, we can see the application. This is a container and application. Here in the backend as well, the same. There is a application for backend. Console, this is like a database or something like that. Okay. So for whenever we set up the service for each file, okay, the front end we need to expose to public, right? So we can set up a load balancer for the front end. So we need to create a service.yaml and define the service type as load balancer. And the backend. So backend we need to make it as secure, right? So we don't need to expose everything anywhere. Okay. So we can use cluster IP. So it's only internally accessible. Got it.
How about if front and back end has to communicate with each other, right? So we can
That's
make use of
for that actually there is a policies there like network policy. So using the network policy, we can define everything. Like for example, we have three port. Okay, 1, 2, 3 ports are there, and some requirement are there. Okay, the port 1 can communicate with the port 2, but not communicate with the 3. But the 3 can communicate with the 2 and 1. So in these similar scenarios, we can set up the policies. Network policies are there. Kubernetes network policy. So using the policy, we can set up these similar type of configuration. Which port can communicate with another port and which can't communicate with the like that.
So when coming to the nodes and pods, how like how many in a node, how many pods can we like accommodate in a node?
That's based on the node capacity. Like if you're selecting T2 medium, okay, T2 medium, the T2 medium contain 2 GB RAM and 2 core CPU. So whenever we're deploying application, okay, so for example, we deploy application. So the controller is already monitoring our node health, right? So this is the configuration. Give me a second, I will draw it again. So we have two node. Okay, to node. So whenever we set up in the Kubernetes cluster, we need to define the node configuration. Like here, this node 2 core CPU and 2 GB RAM. So for this second node, this is node 1 and this is node 2. So the node 2 is same, like 2 core and 2 GB RAM. So our cluster has 4 core and 4 GB RAM, right? So using the configuration, we can deploy the application. For example, we deploy one application. So whenever we deploying application, okay. So some scenarios are there. We created an application, okay. We set up, writing an application scenario. So this is sometimes we need to define that application, how much resources that application needs actually. For example, we know this application needs at least one core CPU for running. Okay, so this all things we need to define the YAML. We're creating a YAML file for this application app.yaml, and we define everything like application name, that configuration, everything, and we can define one more thing that is related to the configuration, how much resources the specific application need. So that's we include in a parameter like request and limits. Request is the max minimum, okay, and limit is the maximum. So we need to define the minimum resources for running this application. Minimum resources means minimum CPU and memory. So I am define, okay. For this application, I define like this application need 2 core CPU, at least 2 core CPU it's needed for running. And the RAM as well, it need 2 GB RAM. So that we need to define using the request and limits within the YAML file, okay. And we deploy that application to the Kubernetes cluster. Okay, this is a worker part of the cluster. And in that time, actually, whenever the Kubernetes is taking the application manifest, that Kubernetes is looking for the resources. If the resources is free in that Kubernetes cluster, then it will reserve for that resources and running the application here. So here, so we have total 4 GB core and 4 GB RAM, right? So the specific application taking half. So the balance is 2 GB RAM and 2 GB memory. So similar way, if you deploy another application, okay, the application need the same resources, then it will taking. Otherwise, it's not deploying actually. So we can see the error as well. Like some Kubernetes errors there, like OMM error that is out of memory. So we need to checking the logs, how this, like checking the machines capacity and everything we need to select. In that case, if the application is not running in our machine, then we need to scale up the resources. That's the only option. Scaling means scaling the node count. So we need to scale up another node. So this is the way actually. By default, we did not define everything like the request or limits, but the production application, we need to define everything. Okay. So otherwise, if we don't define, then it will taking normal, default memory. That's all, or CPU. And why we set up in the request and limits? In some cases, if we don't set the request and limits, some ports taking too much CPU or memory. Okay, so we need to stop that type of activity using request and limits. So we can define request and limits within the YAML file, and the request we defined as one core, right? One core CPU and 1 GB RAM. That's the minimum. Also, we need to define the maximum. So the maximum is 1.5. Okay, 1.5 and 1.5 RAM and CPU. So whenever the specific container, application container requesting more than 1.5, okay, in between they can utilize like 1.9, 1.5. If we taking more than or requesting more than 1.5, the application or the application pod or container will go into exit or stopping. So we can ensure this specific application container will taking only in between the request, like the maximum and minimum. Got it. So based on the scenario, how the application going like that to deploying. It's clear, right?
Yeah.
I had one question. On the previous slide, you had a REST API pointing towards the API box. And as I understand, REST and Node have been designed to abstract away a lot of the computer networking so that the JavaScript can just go run outside the browser, and it can run inside the browser or outside the browser like a script. Is there any significance to that using the REST API on
The
Kubernetes
rest
like that?
means, yeah, that's the method actually, only the method, API method. That is REST. So this is the method. REST method is taking the API request from our local machine to the cluster. For example, if we are running kubectl get node, right? Kubectl get node. We need to know the node count of our cluster. So this is a command we running in our local machine and hit enter. This is the API call actually. So it's going to the API server of our Kubernetes cluster, and that cluster taking the request and sending the request to the etcd actually. Not sending actually, it's taking the etcd data. The database is contain everything, right? The node count, port, application, everything. So taking the data and sending to us. So it will display like we have 3 node like that. The 3 node configuration, everything we can see in the console. So that's using the REST method actually.
So the REST method actually ties into the Kubernetes architecture.
Not in the architecture actually. This is outside, I mean, the interaction between local and the Kubernetes cluster via API code.
Okay. Thank you. So it's an API call. Basically, it could be any API. It's
Here actually it's not like it's a API uses HTTP method, okay?
okay.
Using HTTP interacting with the cluster, right? So using that we can create, read, update, delete, lot of operations we can set up using the REST. Representational state transfer.
Yes, the four states of the browser, right?
Right.
Get, post, and add 2 more. I forget.
Yes.
What are they? Get, post, update.
REST post put the patch update.
Get, post, put,
patch,
update,
delete.
delete. Okay.
Delete. Yeah.
Okay. Thank you, sir.
Yeah. Anyone have any doubt? Otherwise, we can wind up, right? All of you. And tomorrow, Monday, we can set up the cluster, okay? We can start different cluster like manage, self-hosted, minikube, like that. And we deploy some application as well.
Can we have the documents related to Docker?
Docker, right?
Mm-hmm.
Yeah, I will share for the Docker part. Yeah.
Thank you.
Thank you,
So we
sir.
can wind up.
Good morning.
Yeah.
Have a good weekend. Have a good weekend, everybody.
Yeah, good weekend.
You too. Bye.
Bye. Bye.
Bye.